This meeting is being recorded.
Welcome, folks. All right, starting to load into the room here. Zoom takes a few minutes to get everybody. Here we go. Get some people joining us. Welcome, everyone. Happy Friday. Glad you can join us to learn something today. All right, we're up to 15. I'm just going to give it a couple minutes, guys, and get the stragglers here on Friday. All right, Christina, one of our regulars. Thanks. How you doing today? Denise. Pat, our NBC folks are with us. Welcome, everyone. Happy Friday. It's a beautiful day here in Rhode Island, so I'm hoping you're enjoying the same kind of weather. All right, I'm just going to give it another minute for some stragglers to join us. And then we want to get going because I think you will be very interested in this presentation today and have a lot of questions, I hope. All right, looks like we might have plateaued with folks entering the room here. Oh, nope, I still have some coming in, but we should probably get going. We are recording it, so. All right, let's get going then. Welcome, everyone. This is our 5th Lunch and Learn webinar for 2023. You should all be muted as you join. I will just ask you to remain on mute until the end, and then we can open it up and you can ask your questions. You can also use the chat and the Q&A functions at the bottom of your screen. I'll keep an eye on that for questions. Type them in as you think of them. I am recording this session and the link will be sent out with the slide presentation on Monday, and it'll also be on demand for NEBRA members. So thank you for joining us to learn about DryVac, a dewatering and non-thermal drying technology for sludges. We'll be hearing from Scott Normando, a partner of Sea Level Solutions out of Maine, who is representing the manufacturer. And we also have 4 questions and answers at the end. Dan Simpson, the inventor and developer of the technology. But right now, let me introduce you to Scott, who is the owner of Quality Waste Solutions. And all his work is focused on finding innovative solutions and sustainable and cost-effective waste and recycling solutions through beneficial use, cutting-edge technologies, and strategic partnerships, leading solution providers like Dan's company. He has more than 30 years of experience working in environmental services and waste management. He's worked with clients across the globe, including many Fortune 500 and Fortune 100 manufacturers. And one of the more interesting projects I think Scott's managed involved designing a waste management program complete with on-site treatment, waste minimization, green purchasing, and creating recycling plans for a luxury resort in the Bahamas. That sounds like a fun job. He has a Bachelor of Arts in Biology and Environmental Studies from Bowdoin in Maine and a Master's in Business Administration from Revere College. I'm excited for you to hear about this technology to reduce sludge volumes. So let's go ahead and hear all about it. I'll stop sharing my screen and I'll have Scott take it away.
All right, let me get the screen sharing going here.
Sure.
All right, welcome everybody. Thanks for taking some time out of your Friday. Hopefully this is beneficial to you all. So again, my name is Scott Normando. I own a consulting company called Quality Waste Solutions, and I'm also a partner in a group called Sea Level Solutions. As you heard, I have extensive experience in waste management and spend a lot of my time in the last few years working with innovative technologies to solve problems that conventional technologies have left gaps for us to figure out. I'm working with DryVac on their behalf to help them with business development and identifying projects. and meeting people like you to learn about the technology, because it is a very, very good tool and a good solution that we need more people to know about. Dan is with us here, Dan Simpson. He's the inventor and owner of DryVac. He has over 50 years experience as a business owner and inventor, and has invested more than 30 years in DryVac. And he's been working hard on improving and coming up with new versions of the technology to make it even more efficient than it has been. So why are we here today? What's really the root cause of what we're trying to solve? Biosolids and residual management efficiencies, and everybody on this call, I'm sure, knows what that means. The beneficial use of biosolids or residuals are becoming increasingly difficult to manage, and the reduction in land application sites and changing regulations and the looming specter of PFAS are really putting a crimp into our beneficial use and proper management of these materials. I'm in Maine. I'm sure all of you know the challenges that we're faced with here. That's a sort of a unique situation that's compounded by a few things, but there's really a very, very problematic situation we're dealing with here. And we're trying to come up with both short-term and long-term solutions, and hopefully other parts of the country won't mimic us, and we'll come up with a more streamlined approach to managing residuals and biosolids. Unique to us here in the Northeast, there are relatively few alternatives as land application options dwindle. There are few disposal options, and costs are only ever increasing. So as a result of these variables, we have increased costs to the POTWs and industrial wastewater treatment plants, and operational and logistical headaches galore. That's the framework. So what's the solution? What are we to do given these variables that we're dealing with? The simplest, least technically challenging thing to do is to reduce the volume. And how do we do that? Quite simply removing the water from the biosolids or residuals. And everyone tries to do that in one way, shape, or form. But if you reduce the water from this material, you reduce the amount of trucks going to landfill, and you have fewer trucks on the road. Transportation is only getting more expensive, and with the lack of drivers available in all industries, again, logistical headaches for both the providers and for the customers. You can help solve the cost and logistical problems by reducing that volume simply by removing the water. And if you're using and looking into waste to energy options, again, burning water never pays off well. So adding value by removing the water to a waste to energy option is always a nice thing to do. So conventional dewatering technologies, filter press, screw press, belt press, centrifuge, doesn't really matter what you're dealing with. At the end of the day, typically you're averaging about 20% dry biosolids or filter cake. So again, it looks to us like it's dry, it's legal to ship over the road, but you have 80% of that is really embedded water. So you're shipping water up and down the road, and you're paying to dispose of water. Just to have it hit home, I'm not sure if any of you have really done this exercise, but it really is quite breathtaking of what we're dealing with. So if you have a baseline of 20 truckloads of dewatered filter cake of anything going down the road at about 20% solids and at about 18 tons per load, if you're able to reduce that down to 50% moisture, you've gone from 20 trucks to 8 trucks. So you have a 12 truck reduction and a 216 ton reduction in disposal costs. And then you can see the impact of going an additional 10%, an additional 20%. So removing water is quite impactful from a cost and logistics standpoint. If we get it up to 90% dry, you have over 15 trucks eliminated starting from 20, and you're no longer paying to transport and dispose of 280 tons of material. So again, that's quite impactful. And then if you're able to reclaim that water, in some applications we are, you can see the volumes there, up to 70,000 gallons of water returned for beneficial use. In the East here, it's not that big of a deal, but out West, that is a very, very big deal. So moving on from dewatering to drying technologies. Once you get it to that 20% and you want to get to 60, 70, 80, 90%, what do you have for options? And typically in the market, everyone says that the conventional technology is a thermal dryer. That's what you have available to you. The problem with thermal dryers historically, they're costly to purchase. They're costly to operate, huge carbon footprints because of all the fuel it takes. They do not scale well to small facilities, and they're dangerous, or can be dangerous. And to give an example, I spoke to the city of Fayetteville in Arkansas a month and a half or so ago, because I found out that they were looking for an alternative to help them manage their biosolids. They had a thermal dryer in their facility for a number of years. And I saw the headline in the Arkansas Democrat Gazette. And the headline was Fayetteville evaluating biosolids options after dryer malfunction. Well, that malfunction was the dryer blew up. And not only did it blow up once, this was the second time it blew up. So they had a system down for a number of months, and they did some research, and in their infinite wisdom came back and decided they were going to buy another thermal dryer. So I like to point this out and sort of make fun of them a little bit, but at the end of the day, it's really not their fault, because they don't know that there are viable options to them. So they thought that buying another dryer was their only choice to help them reduce their biosolids volumes. So that's why we're here today. I want to introduce you to the DryVac technology, talk to you about why it works as well as it does, how it works, and what the value proposition is. We spend a lot of time talking about biosolids, and a lot of the people here are working on the biosolids, but it can be any sort of sludge that you're dealing with, any sort of wastewater that you're dealing with. If you're producing a filter cake, then the DryVac is applicable to you. So organic and inorganic sludges, this technology dewaters and dries in one operation. So instead of having a dewatering operation with a filter press and a screw press, and then a drying operation separately like a thermal dryer, this piece of equipment does both. We can get the solids dried to over 99% if that's how far you choose to chase it. It's quite simply a function of time. For biosolids, the DryVac technology will have 100% pathogen kill, and it creates what's called a Class A equivalent biosolids because of that pathogen kill. And you're able to recycle the water if you choose to do that. This is how it works, and this is what it looks like. So if you see the picture on the right, most of you are looking at that and saying, well, that's just a plate frame filter press. And it actually is. That's how it started its life. So as at the start of the cycle, the wastewater will go through that system and act as a filter press, but then at a predetermined time, and that typically is anywhere from about 16% up to 20% solids, the plates will actually seal themselves off. They'll expand and form a seal. And then we'll pull a vacuum on the interstitial space between those plates and pump in low pressure steam. And then the system acts as a heat exchanger. So with the vacuum coupled with the temperature of the steam, it allows us to sustainably and cost effectively drive that moisture out better than typical conventional dryers and thermal dryer options. So you have the feed cycle where the sludge is fed into the chambers, the vacuum is applied and the steam is applied. And then at the end, the plates recede and the dry filter cake quite simply just drops out of the bottom. So this is what it looks like on an efficiency curve. So you see on the blue line, that's a standard filter press. Once it squeezes and achieves somewhere in the 20, maybe 30%, but quite realistically, usually 20% range, that's as good as it's going to get. And I don't care how long you squeeze that, that's what it's going to stay. So you're going to get about 20% dry. But with the DryVac, you see that over time, you have more and more of that moisture driven off. And for each customer, they have to make their own choice based on the variables and the costs associated with their application. At what point do you want to stop chasing the level of dryness? Does it make sense to stop at the 60 point, at the 70, at the 80, at the 90, 99? You can easily get it to well over 90%. It's just a factor of time and how far you want to chase that. And I like to say the genius in this technology is in its simplicity. Eighth grade physics concept. The lower pressure, because of the vacuum, allows for vaporization of water at lower energy inputs. That's how it's as efficient as it is. Technology does not involve sophisticated and hard to replace parts at risk of failing. It's not an overly complicated system. Basically, you have the proprietary plastic plate frames. That's what expand and allows you to draw the vacuum. Other than that, it's just a frame. It's a stainless steel frame, has stainless steel or steel frame, stainless steel piping, welds to connect everything. And then you have common off-the-shelf pumps and chillers and boiler components that if anything ever breaks down, it's a quick fix. So it lasts a long time with very little maintenance required. You can see here that pile of solids there, that actually is a pile of biosolids. And then you have the filtrate. The typical filtrate coming off of the system is a mixture of filtrate water and distilled water. Usually, I know everybody is different depending on where you are geographically and which state and which regulations you're talking about. But typically, this is a dischargeable water. It can go back into the headworks or otherwise be further treated for reuse. But it's very clean and typically dischargeable water. And again, the industry served is anybody that has a wastewater system and produces a sludge or a filter cake. So we spend a lot of time talking about biosolids, and I've been spending a lot of time in Maine talking to biosolids POTWs because of the issues we're having here, but it doesn't matter the industry. And I like including this picture because we're working with a Fortune 100 consumer goods company, and they have a tissue division making toilet paper and paper towels. You can see that their input sludge there is coming in at 2.5% solids. They were beneficially reusing some of it. Most of it was going to landfill after they were using a screw press to get it to about 20% solids. So we ran the test on the input coming in at 2.5% solids. You can see the clean effluent coming out of there. And that's what the filter cake looks like for this opportunity. It binds a little bit better than most filter cakes because it's just cellulose, so it forms a really nice cake, almost like a biscuit coming off of there. And what we're doing is we have people clamoring for us right now to use this as a feedstock into their processes, and we can get revenue for this material now, where previously it was a line item expense for the customer. So municipal POTWs, paper mills, food production facilities, mining operations, on and on with these industries. DryVac has demonstrated and proven that the technology works. And if you ever go to the DryVac facility in Rio Vista, go into the back storage room and you'll see, dried samples of almost any and all of these types of applications that have been performed over the years to prove that it works. The benefits of DryVac is quite simple, really. First of all, it's proven and flexible. Now, I say I work with innovative technologies, but that does not mean it's unproven. We're not talking about having a technology that's in someone's garage on a bench scale test that is looking to get off the ground. Dan's been around with DryVac for over 30 years and has deployed well over 150 of these things worldwide. It's just not considered conventional technology, so it's considered innovative. The feedstock tolerance, again, activated sludge, primary sludge, digested sludge, industrial sludge. It doesn't matter. It works on all of these and it has very good results. Very low maintenance. Again, not a lot of moving parts that could fail. It can be an automated operation, and it can be constructed in modular fashion, and it can be mobile. It can be put on a trailer. So it scales down nicely. I typically don't ask how well a technology will scale up. I typically ask how well a technology will scale down, because there are a lot more customers that are smaller that could use this than the larger ones. And you can scale it to large as you want to go, but the beauty of it is it does scale down nicely. It's safe, no explosive dust environment, very low pressure steam that's safe to use. It kills pathogens, produces a Class A equivalent biosolids, and there's no odors. From an environmentally friendly standpoint, it's a clean closed loop process. The steam never comes direct contact with the sludge, so there's no air emissions. You can recover the water for reuse. It has a very low carbon footprint, so both directly but then indirectly for taking the trucks off the road, so scope 3 emissions. And you can make use of waste heat to, if anybody at their facility, this typically doesn't happen on the municipal side, but for an industrial, if you have steam on site already, or if you have waste heat, then you can utilize that waste heat instead of needing a boiler for the system. And then obviously the obvious value proposition is the reduction of volume going to landfill and the trucks being taken off the road. And here are just some pictures of some past deployments of the technology. It's a good picture of a system in Rio Vista, California, and then a much larger series of systems. I think there are 4 presses there, all side by side in sequence for deployment overseas. And then here's a collage of various deployments over the years. So if anybody's interested in pursuing more information or would like to have their material tested, how do we make that happen? Well, first, if you're interested, Dan will tell you this. He's always willing to host visitors coming out to his system, out to his facility. You can inspect the system, you can run some samples and watch paint dry once you get it loaded until it comes out the other side. But Dan will show you around the facility. You'll see his manufacturing operations, and you'll see a pretty neat restaurant where he'll take you to lunch. And you can also send samples to him for testing, and we can run those and see how your particular material reacts and what it takes to get it down to the level of dryness that you're seeking. For us to give a ballpark price and size, typically we need some very basic information. We're looking for the flow rate to where the DryVac system would be incorporated into your system. So I'm not really concerned with your entire facility's flow rate. What I'm looking for is if you're using a belt press or a screw press or centrifuge or whatever you're using, I want the flow rate going to that piece of equipment. And I also want the percent solids at that point. Those are the key data points that we're looking for. When we size the system, we typically assume 24 hours a day operation unless told otherwise. This thing is relatively autonomous in how it operates. If we have to size it for only 8 hours a day operation, then we have a pretty decent CapEx expense that is sitting dormant for 16 hours a day. So to get the best bang for the buck and the most efficiency, we'd like to have it operate for as much of the day as practical. We'd like to know if steam is generated on site so we can tap into that. Otherwise, we need to accommodate a boiler. And if we need a boiler, then we need to know if natural gas is available on site or if we have to factor in other fuel sources. And then anywhere from 2 to 4 5 gallons of your waste sent to the DryVac facility for testing, so we can determine how we can best dewater and dry it for your material. And it always amazes me for the various POTWs. They could be 20 miles apart, but at the end of the day, the sludges are always different. They always react differently. For the same, what's supposed to be the same material, no two are the same. So we need to play with them a little bit to determine the best operations. And then if we're able to get the utility costs and the sludge volumes and disposal costs and polymer and chemical costs, then we can help determine an ROI. Some customers like having us do that and working with them on that. Others say, we'll do that on our own. So it's entirely up to you. So it's a short presentation. I'm hoping there's some good Q&A here because there's not a lot of complicated rhetoric that we need to go over. It's a simple system. It's an effective system. It has a great value proposition, and it solves a lot of problems that we're dealing with now. Quite simply by reducing the volumes going over the road, it opens up a whole range of other options that you otherwise may not have available to you if you're dealing with a dry filter cake, if you're dealing with a far less quantity filter cake than you otherwise are working with now. So that's where we are.
All right. Yes, we do have some questions coming in for you, Scott. I'm going to stop sharing your screen there so we can see you. And we'll start in with the questions. And I have a few too, but let's see. The first one that came in was, what's the volume that you can run per day? And how well does it work with septage waste?
Dan, you want to tackle the questions?
Yeah, sure. The volume is dependent on obviously on the size of units that we install. The largest single unit today in a 2-meter plate is 20 cubic meters of volume of sludge at 20% and when I say 20%, you know, that's a number that's sort of an average. It varies depending on whose sludge it is and how much chemical we want to use. And typically everybody wants to keep the chemicals to a very minimum. And so that affects the percentage, what we call 0 hour, what it gets to before it goes into the distillation phase. So at that point, you can put, you know, it's practical to put 7 to 10 of these units together. We've had 4 of them together in one installation. That was that large pile that you saw of sludge. That was one afternoon's run of sludge, by the way. That's a lot of material. That material they were drying to 95% dry. That was the number they picked and wanted to live with, and it worked just fine. That was roughly 15 years ago. We've had major improvements to the equipment now, and it runs much higher volumes than it did before. And it's obviously it's a batch system. So if you've got 5 or 6 units, it's virtually running and dropping all the time. And let's see, we wanted the size cubic foot. As far as septage goes, it's no different than a primary sludge. We are permitted in Nevada right now. We're taking raw sewage with everything, no grit removal, no nothing, right out of the pipeline into a system. And then the state thinks it's a great deal because we've got a lot of little tiny places that can't afford a lot of concrete. So basically this solves that particular problem. I don't know. I hope that answered the question.
Yeah, I think so. I think there was another similar question about the maximum amount of sludge that can be fed into them. And you did give a number. It was 20 cubic meters per.
Correct. Per batch, per single
batch.
unit. So if you've got 5 units, it's 100 cubic meters. Now we have built 3-meter plates. We're working on a 4-meter plate. Those plates get into the 100 plus cubic meter range, but that's typically not necessary in a wastewater plant. That's more for the mining industry where we're looking at trying to run huge numbers per day and per hour, and where you want, you know, like 500 cubic meters of material at a time. So different world.
No, that's interesting. You note the difference with wastewater. And I was just curious if you have a operating system at a treatment facility somewhere.
Well, there have been. We went into to shut down for 10 years while I was dealing with a potential health problem. They told me I was going to go bye-bye, and I didn't. I stuck around. But just to kind of give you a shot in my office here, I keep this in my office. This is primary waste out of the Vallejo wastewater treatment plant. And you can, if you can see that, it's about roughly, it's about 3/16 to 3/4 or 3/8 of an inch thick. It's 99% dry when it dropped out. Obviously, it'll suck up a little bit of moisture, but because primary's got so much fiber in it, it's, you know, this is pretty tough. It's hard to break it, but you can drop it into an auger, and the auger will chew it up into little pieces, and then it can be used for whatever you want. It makes a great fuel. In fact, we're the influent unit in Nevada that's just everything. It's everything, you know, recognizable solids, everything going through into the DryVac. That's a pretty high value fuel, and it's very small, but the local cement factory is taking that, is going to take that material for the client and actually pay their trucking. So that helps a little bit.
Yeah, and that's way better than sending it to landfill.
Yeah, it is.
But I can certainly see that's an advantage even at a landfill. I'm just curious if you know if it reabsorbs moisture in the landfill.
Some of it does, some of it doesn't. It depends on how it's treated, and it depends on the chemistry used to coagulate it. We used to have a product called Rio Grow that the Future Farmers of America sold back in the 90s, and we pulled it off the market back in the 90s because at that time we were reading all about hormones and different things in wastewater. And since our company was the only deep pockets in the game, we decided that we didn't want to 10 years from now get sued for somebody having 3 eyes and 7 ears. And so basically we pulled that off the market, and then time went by, and now we're looking at it, and except for PFAS, it'd still be a good product. But the reason I mention that is that we used to put that in big stacks about 4 or 5 feet tall, and it sat out winter after winter and didn't rehydrate at all. And that was a waste activated sludge, aerobically digested. So, but it would not rehydrate. You could take it and throw it in a bucket of water and it would sit there, forever.
Yeah,
EPA
cool.
tested it. The EPA tested it, said it was the best fertilizer that they'd ever tested in their gardens in Pennsylvania. Came back and said, and by the way, it's a Class A material, and then it's so much better, we've decided to call it EQ, Extreme Quality. So, and we thankfully took that designation and smiled all the way to the bank. So,
And depending on how you interpret the question, the max sludge that can be fed to them, as long as it's pumpable. So if the question is asking from a solid standpoint, it needs to be pumpable to go through the system. So this is not a typical drying system where we take the dewatered material and then dry it. We can't take the dewatered material and then try to process it. It needs to be pumpable. So we're taking it in, typically 1 or 2%, but it can be much higher than that as long as it's pumpable.
I'm going to argue with you, Scott. We've actually taken dewatered centrifuge and belt press material and run it back through our unit because it's not practical to do that. You're correct that way because it's a waste of energy and time and money. But as long as you can pump it, and much of that material, because it's not 20%, it's 10 or 12%, it will pump and you can put it in. So I started something we can talk about.
But that's great. You guys all recognize, obviously, yeah, every sludge is different when it comes from a wastewater treatment facility. So obviously you got to spend some time up front with these folks to kind of get an idea. All right, we have more questions, one of which is about PFAS. I'm assuming that there's no destruction of PFAS in this process, but a lot of our processes don't have that anyhow.
There are ways to do that, but not specifically because of our equipment. The good news for us is that we catch all those chemicals. The bad news for us is we catch all those chemicals.
That's same for us, right? We know where it ends up.
But we are working with a companion technology. We're in dialogue with them now. And long term, I think we'll have a companion technology that we can pair with the DryVac that does have the ability to treat PFAS and also help the DryVac operate more efficiently. So again, DryVac itself is not a treatment technology, it's a dewatering and drying technology, but we can be paired with other technologies that treat the PFAS just upstream of the DryVac.
But I think one of the advantages is it's not ending up in the air stream.
No,
absolutely.
No.
We know we've been dealing with it in the solid stream for a while, but I think there's a lot of questions when it gets into the air. So,
and that's another thing. Air quality has ruled us to be absolutely free of any contamination. We have no contamination from air. That we don't put anything out. So
yeah, I mean it's a vacuum.
Yeah, it's like my brain. We operate in a vacuum.
I was just waiting for a joke to come. I know. Thanks, Dan. Thanks for taking that one. All right, here's another question about the heating requirements. Can you use methane? That's a great question. We have a lot of methane. I don't know if we can channel it and use it, but.
No, we do. And methane is wonderful as long as you've got enough. Well, it doesn't really matter if you have enough. We have one facility in the Bay Area that has a flare running in the view of everybody that sits around the San Francisco Bay. And their big goal for us a year ago when we started working with them was to get rid of the flare. So what's going to happen is we have a dual fuel boiler, and as long as there's enough methane coming in, it runs on the methane. If it needs a boost, it gets propane as a kicker. We continue to burn the methane the whole time because you can't. It's a pain in the butt, obviously. Everybody knows about trying to compress methane. It's expensive, and it's not something that a little plant wants to do. So in reality, yes, and it's wonderful to have it.
Yeah, I mean, it sounds like you guys are totally focused on minimizing waste in any way. So this is great.
Yeah, the other thing we do is all the heat coming out of the DryVac goes back into the preheater for the boiler. So we recycle 100% of the heat that we create. It goes around in a big circle. Kind of like a cogen set.
Here's Here's a question about specifically about the treatment facility that you're working with out in Rio Vista. They're wondering so what's the end use of the dried material from Rio Vista? And does it meet the Senate Bill 1383 diversion of organics from landfills? Are you guys familiar with that at all? It
Oh,
includes
boy.
biosolids, yeah.
Yeah, no, 1383 has been a real wake-up call. In fact, I have a meeting on Monday with the city of Davis where we're looking at running both wastewater and food biosolids, which we've done, and we have a in-house order to run food biosolids down in Texas. But the end result of Rio Grow is that it's been up, and it still is today. You can apply it, for agriculture or any non-edible, anything people aren't going to eat. I don't want people putting it on their tomatoes, obviously.
Golf courses,
Yeah,
landscaping.
exactly. Yeah, farming, agriculture. I'm also a rancher, so I appreciate, what it can do. But we all know what we're faced with. We got PFAS coming, and so the current problem is, okay, now we've dried it, we reduced the volume, but we still have the next step. That's the reason in Nevada it's going to the cement kiln, because it runs at over 1800 degrees Fahrenheit, so it does destroy the PFAS, and any of the other sneaky little chemicals that are hanging out in there. So there's no
Yeah, that
magic.
sounds like a great end use for it, is as a fuel.
Yep,
in
and
a
that's what
thermal
it's gonna.
process.
I think in most cases, like we've got one group of wastewater plants that are trying to organize a co-op. There'll be 24 facilities running DryVacs, feeding material into a gasifier, which will then generate power to run one of the particular wastewater treatment plants. So it's, there's the imagination right now, and we're all kind of sitting around not knowing what's going to come down in the way of regulations, and so it's a difficult time
Yeah,
for everybody. The good thing is
absolutely.
we do capture it, and we can get it to someplace where you can use it as a fuel. And most wastewater dry solids make a reasonably good fuel. Some of them are better than wood. So
Yep. No, that's great. And it sounds like you're just doing it through collaboration and partnering with different peoples to make sure you're getting the
correct.
best out there. All right, so I think that's it for questions. If anyone has a question, you can raise your hand now, and I'd be happy to unmute you. There's a little raise hand function down at the bottom. But one question I had, can you like ballpark cost figure for maybe, I don't know, somehow a small facility, one unit? Not really.
Yeah, you can. I can give you an example of a small facility in the Bay Area. It's about 1.6 MGD, and they're right at about $1 million complete. The biggest problem there is it's a facility hanging off the side of a rock cliff, and so the construction for the support equipment was more expensive than normal. So it could have been slightly less than that.
So that's on the high side.
Yeah, it would be
because of the construction issues. All right. No,
No.
that's helpful. I appreciate that.
Yeah.
Anyone else got any questions today? Hang on, let me check. I think I have one more. Nope, that's it. And I don't see any other hands raised. So I'm gonna thank you two. Very interesting, Scott and Dan. I really hope this takes off.
Well,
And
thank you.
it has taken off, but I hope it expands into treatment facilities here. But I want to thank you for joining us, and thanks to everyone who's spent their Friday lunch with us today. Our next Lunch and Learn is scheduled for June 23rd, when you can learn more about landfill capacity for biosolids in the Northeast. There is none, but we'll hear about it, and I'll be sending out more information on that later. But check out our events page. We have these scheduled through October. And if there's something you particularly want to lunch and learn about, please let me know. I'd be happy to make that happen. So thanks again, everyone. Thank you very much, Scott and Dan, and have a great weekend, everyone.
Thank you very much.
Take
Bye.
care. Bye.
Bye.